Hey everyone, today I'll be creating a tutorial on how you can visualize the effects of touch on your brainwaves and heart rate. Here's a little sneak peek of what you can create at the end of the tutorial. I referenced this video by Don't Just Exist to link Arduino to TouchDesigner, as well as this video from Paolia for the visualization aspect. I have linked both videos in the description below. Let me first introduce the hardware components that I'll be using. I'm using an Arduino Mega 2560, but you can use an Uno as well. Attached to the Arduino is a MindFlex EEG brainwave reader. I created this ugly pressure sensing glove prototype where I attached a pressure sensor to each fingertip. Each pressure sensor is then connected to the Arduino. Next, I attached a pulse sensor to the Arduino. It measures your heartbeats per minute, also known as BPM. This is the Arduino code that I'll be using. I made use of the Brain library and the Pulse Sensor Playground library. I've linked the code as well as all documentation in the description. After you've compiled and uploaded the code, if everything is connected properly, these numbers should show up in the serial monitor. The first 10 numbers are data from the brainwave reader. The second last number is the BPM from the pulse sensor. And the last number is the average pressure of all 5 pressure sensors. Now for me, in order to successfully link Arduino to TouchDesigner, I had to close Arduino IDE, open the code again, compile and upload the code again, but this time do not open serial monitor as it might screw up the serial communication. So you compile and upload the code again, and now you open TouchDesigner. I'll be briefly running through the TouchDesigner network that I used before we make the animation from scratch together. There are 3 parts to this network. First, processing data from Arduino. Second, the interactive visual or animation. Third, the interactive audio, which is the sound of a heart beating. I shall first point out the key parts of the network. I made use of serial components to send data from Arduino to TouchDesigner. As you can see, the numbers are constantly being updated from Arduino. It is important that you key in the same port name that you used in Arduino. I then made use of a convert component to organize the values into a table. Then I made use of a select component to derive the latest set of values. Note that I selected the row by index and I wanted the 9th row. I also selected columns by index and I wanted all columns 1 to 12. I then converted this to chops using data2 component. Then I renamed the chops to keep everything organized. Then I split the values up into BPM, pressure, and all the different types of brainwaves. I made use of the math component to process the brainwave data. I multiplied the values of each brainwaves. The greater the concentration level, the greater the multiplication value. Those values are then added up and converted to numbers that determine the change in colors of the animation. Blue is the lowest level of concentration, whereas red is the highest level of concentration. The BPM is then converted to a number that determines the speed of the heartbeat audio. The average pressure value is used to determine the size of the animation. The higher the pressure, the greater the animation size. You can download this network used to process data from Arduino in the description. Next, for the animation, it's very straightforward. I basically made use of noise, feedback, composites, and more noise. Now let's do the animation part from scratch together. First, we'll create a sphere. Reduce the radius of sphere to 0.6 on all dimensions. Change the number of rows and columns to 100 each. This will allow greater detail in the animation. Next, add a noise. Reduce the amplitude to 0.16. We don't want it to be too intense. Then add a transform. We'll get back to this later. We'll map the change in pressure to the uniform scale of the sphere. Add abs time.seconds times 0.5 to the z-axis of the transform. Add the typical components required for SOPs, geometry, lights, and camera. Add a render top. Set the resolution to me.parent width and me.parent.height respectively. Add a null. Add another null and move it to the end and label it BG. Set it as your background. Add a PBR and map the material onto geometry. I'm just going to set a random color first. The color of the material will be determined by the brainwave reader data later. Add a noise. Change the resolution to me.parent.width and me.parent.height respectively again. Period, set it to 0. And add a displaced top. Link the null and noise to displace. Change displace weight to 0.01 on both axes. Change offset to 0.72 on both axes. Under noise, add time.seconds times 0.5 to the translate element of the z-axis. Add another noise and change the period to 2. Change harmonics to 0 and exponents to 1.31. Change amplitude to 2 and offset to 0.6. In transform, set the z-axis to abs time.seconds times 0.3. Once again in resolution, add me.parent.width and me.parent.height respectively. Add a level and change the contrast to 1.95. This will make the edges of the animation more defined. Change the RGB under output to just noise. Add a composite top, link level and displace to it. I like to play around with different operations to see what happens. But ultimately I chose outside luminance. Open palette, under image filters, select feedback edge. I change the edge color to blue. Add a null followed by feedback. Map keyboard into the feedback pulse. 1 on keyboard would then create the animation to restart. Oops, the subtitles are wrong, but add a noise. Change the harmonics to 10 and amplitude to 0.21. Under output, change RGB to noise and turn monochrome off. Add slope top. Link it to feedback. Change 0 points to 0.606 and strength to 100. Add a composite top, link noise and slope. Change composite operator to average. Add another composite top. Change operation to over. Link COM2 to COM3 and drag COM3 into feedback. Add a displaced top. Change displace weights to -0.01 and 0.01 respectively. Change the offset to 0.6 on both axes. Add a level top, change the opacity to 0.96. Something went wrong with my connection, so I'm fixing that right now. It should look like this. It should now look something like this and reset the animation by pressing 1. Here, I'm just playing around with the scale, edge strength, and source gain of the feedback edge. You don't have to follow these exact numbers. Add a ramp. Set its resolution to me.parent.width and me.parent.height. Add a lookup and link ramp to it. This makes the background black. Add a HSV adjust top. Add a HSV adjust top and play around with saturation multiplier and value multiplier till content. Whoops, something went wrong here. I'm just fixing that. Add an edge top and change the strength to 25. Add a level and change the opacity to 0.6 to around 0.65. Add another composite, link HSV adjust and level to it. Change operation to over. I'm just going back to the sphere to decrease the radius a little bit. Add another edge, I'm keeping the default values. Add a level in case I want to decrease the opacity. I'm changing the black level of the edge to 0.569 as I want it less intense. Add another composite top and link level and the other composite. Change operation to add. I'm changing the black level here to 3 to 1 because I don't want it to show up anymore. Add another noise, and this is for a grainy effect. Change the period to 1. Add a level. Change opacity to 0.1. Add another composite and composite all together one last time. Change the operator to maximum or whatever you like best, and that's it for the animation parts. You can now map data from Arduino into the different components. I like to keep things organized using Annotate. In In order for you to view the animation without being blocked by the annotations, zoom out the component, right-click on Project and select View. Go back into the project and add an Out top. First, let's map the average pressure to the size of the animation. Drag the pressure now into the uniform scale of the transform component. Because I'm currently not pressing on the pressure sensors, pressure equals to 0 and scale equals to 0, and hence the animation would just slowly dissolve away. Next, you want to map the brainwave data into the material color. I want the colors to become more red as the brainwave data becomes higher. Right now, the values are at maximum because I'm not wearing the MindFlex reader. I mapped the values to the PBR as such. Lastly, for audio, I'm using a track of a heart beating. I want to increase or decrease the speed according to the data from the pulse sensor. I will hence map the frequency from BPM to the speed of the audio file in chop. I changed the frequency and bandwidth of the audio para chop to ensure that the pitch would not change too much with the speed change. And that's it! Moving forward, you could try out different sensors such as temperature, distance sensors, and map them to different components on TouchDesigner. You could also perhaps take it one step further with the brainwave reader and have different animations or audio for the different specific brainwave states. It would be really cool to be able to map out the different pressure points across the whole hand to see which areas evoke the greatest change in BPM and brainwaves in sort of a data visualization project. If everything is right, here's how it will look. I hope to make more similar projects soon. Thank you, and you can find me on Instagram at Pepsicles.